Right, and we are live. Hello everyone. How are we doing today? Yeah, so today we are going to do something very exciting, which is we're gonna try making the scrolling actually work for everything on a page, because currently our browser doesn't really works with doesn't really support scrolling for elements on a page. It only supports scrolling the whole page, so it's kind of useless at the moment. So right now what it can do is can scroll the whole page, but if within the page there's a scrollable element, you won't be able to do this. So that's the aim of our stream today. Gonna try making it works for everything on the page. Yeah, I'll probably announce my stream on Twitter first. Alright, yeah, so what happened in the last stream is we have got mouse moving support. So we have basically we have captured the mouse movement from the UI, and then we pass it over onto our render engine. So it's so that we can now track which element is being hovered by the mouse, and that is very useful because in order to detect which element to scroll, we need to know which element is being hovered. So yeah, so that's required mouse movement trackings. Yes, which we already merged. So now we will have to merge the master branch onto our branch because our branch doesn't have that code supported yet. Rebase? Probably not, just merge it. Yeah, I don't really like rebase usually. Oh. Conflict. Conflict layout box. Okay. Our box. It's the conflict. It's mouse over. I have no idea. I need to check the old code. Totally forgot. What do we put there? Because I remember we removed the scroll height and just decided to do the computation dynamically. Okay, so it still had the old code. So yeah, technically you don't need you don't need a scroll height, but you do need a mouse over. And what else to solve this one? Okay. Yeah. So in the previous stream we decided to replace the scroll height with a dynamic scroll height computation function, so it's easier to keeping track of the scroll height. Yeah, it's gonna produce less bug, hopefully. That seems about it, I think. That looks good enough. Edit. Yeah, it's cool. Now we have all the mouse tracking code and stuff. Let's make sure that it can compile though. Yeah, so that can compile just fine. That's good. Okay. So now we can start doing some mouse tracking. No, not exactly mouse tracking. More like handling the correct element for scrolling, like detecting the correct one for scrolling, which I think is in framed press, I guess. But this one is not used anymore. Okay, so we have scroll here. So yeah, as you can see that at the moment it's just supporting scrolling for the root node, which is the page itself, and that's not ideal because within the page there might be other elements that need scrolling support. So need to find right element for scrolling, which is usually the element that what do we say, the element that is mouse over but at the bottom of the tree. So in the DOM tree, you have something like diff, and then within that diff, you might have another diff, and within that one, you might also have another diff. And let's say if all these three diff are, equal in their size, and you have mouse over on one of them, technically all of them is mouse over. But when we send a scroll signal to the browser, we expect the bottommost one that has scrolling, that is scrollable, to scroll, if that makes sense. Like, if this is scrollable, and if this is not scrollable, then we'll scroll this one. But if this one is scrollable, we don't scroll this one, we actually just scroll this one. I think that's the correct behavior. I mean, if it's not, we can always change it. But for now, we'll stick to that. Okay. This scrollable container, that is what we want. So how do we search for that one? Say roots. Okay, so we have something called find first ancestor. But this is for finding ancestor. We need descendant. So let's make one for descendant. But not first one, but more like last one. Right, not last one, deepest. Descendant? Damn, I forgot how to spell descendant. Descendant, yeah. Yeah, I think that's right. Find a deeper descendant is just gonna do self dot or each child. We do it for a child here. No, probably should do this one. Or child in self dot iterate children, perhaps. That work? Say none. So it's okay. So for child in the children that we have, what does that do? Children iterator, parents, current node, first iterations, first iteration do that. Y is next sibling. Okay, so it's just iterating one level. That's good. That's what we want. I was just making sure that it's not iterating through the whole tree, the whole subtree. That's what we don't want. So find this. Yep, where's the code? Oh, is that in the tree? Damn, okay. Thing is in the tree code. Tree node. Yeah. Okay. So in the tree node, we iterate through the children if the child match the callback, then we return some child. It's the deepest, so let's call result. It's none. If it's matched, then the result go to some child. So we're gonna save that into the result. Move there. Okay, let's clone it. Okay, it's movable. Okay, so we just move that into the results, and then but we don't return it yet because there could be a different node deeper within that that is actually the one that we want, because we are finding the deepest descendant. So result child. This is a bit difficult because I'm thinking about this case, like, what if a div has a div which also have another div and another div? Do we call this one the deepest descendant? Technically, yeah, but no. If we apply scrolling on this div, do we scroll this one? Do we scroll this one? Because technically they are both deepest. Let's just take this one for now, and we'll worry about the other one later. So I want to recursively call this function. Let's do it recursively. Yeah. So if find descendant their level, because, you know, in case there's a diff, but within this diff there's another diff, and that another diff there's also another diff. So technically these are two deepest, but if this match the condition, we don't really want to take this one, we want to take this one instead. So in the end, what we might have to do is comparing their levels. So let's say at the end of the step we find those two diff, but one diff at the level 1 and then the other one has the level 2, and we want to take the one with the deepest at the deepest level. Yeah, let's do that for now. Options might be a tree node, and include their level as well. Yeah, could it be USI? Just, yeah, probably not USI, but it's probably fine as well. What is this one complaining about? Cannot use generic parameter from outer function. Alright. How about now? Perhaps we use descendant. We could use a closure instead, so we don't have to worry about those other thing. So this closure takes in a node. It's a tree node. We'll do node or child in node but children. If child dot has no child, yeah. If the children has no child, then we know that's the deepest one. And we collect that one. Let's matches descendant vector. Then we say match descendant push the child. If the child match the callbacks, this one, if the child match the callback and the child has no child, does that mean that it's the deepest child and it's at node? Then we push them into the match descendants and then turn the match descendants. Yeah. Should we? I mean, hang on. We can just do deepest level 0, and then we can just say void child. Let's do level. Let's pass in. Let max takes in a level as well. Because I'm thinking that we can just keep track of the level as we go through the children. So if the child has no child, let's match the callbacks, and then this is difficult because we need to write this. We need to level that's equal to 0, and let's say we call the first iteration on the root the level 0. That will cause the root to travel to the child with the level +1, and perhaps it's the same thing for every child, and the child of the child as well. So, and at the end of the function, we might just do So let's say that we match this one, we return it, then this one returned the child with the level, then this one will compare the level of this one, and since this one has a deeper level, take this one, ignore this one. Cool. Yeah, so that's the flow. So first we need to keep track of the level of which the elements is matched, and then at the end of the finding process, we'll just say, you know, okay, you have the level that is deepest, will take you. Yeah. And not return. If there's 3 of them. If there's 3 of them and all 3 of them match. Ooh. No, that's not fun. Okay, so in this case we might have to consider, do we want all of them or do we want one of them? Let's just do one of them at the moment. Find the first deepest descendant. So if you match this one, and we'll take it. Let's hope that that works. Child. Return a child level. Otherwise, all the same thing. Match descendants with a child level +1. Well, if let some results, because there might not be any, so there's some result and we turn that results. Oh, yeah. Yeah. Let's do results equal that. If results sum turn results well, not really. Let's do this. Let's mute deepest level. So the deepest level start from 0. And so trying to match the descendant with the level increase to the results. And then if the level is more if less some well, if it's go down here, then it should return none. But there is some child, some nodes level results. If level more than deepest level, then or deepest level to the level or the new one. And child and that we return the deepest child. Yeah. Oh, that's not gonna work, isn't it? Oh. Child level like so. Okay. Deepest child map. Child. And then deepest level. How about now? What is this one? Cannot find function. Alright, so you can't do recursive on closure? Really? You can't? Recursive closure. Yes. Ugh, no. Well, okay. I don't want this though, because it's forced you to pass in all the types from the how to say it, from the class. So if you need to reuse the generic parameter from the outside class, then it's gonna take a while. Well, let's do that then. Function. So yeah, so we need the T for the tree nodes T. Debug. Tree nodes T. T tree node. Okay. So mass descendants. Now we need a callback. Node level to callback. F. Can we do F? Okay. Let's do this T and F. Where T is bug plus T, and F is FN tree node T throw us up in, yeah. And we need return types. So the return type should be an option of the tree node T and the level USI. Right. There should be some. actually we can just do this shorter. Should be a 2. Borrow after move. Borrow instead. Yeah. Okay, so let's go through. So at first we start deepest level is 0. Say the deepest child is none. And then we go through the list of children. The children has no child. It's the deepest one. And if it's matched to callback, then we return it. We return the child and the level of it. Otherwise, we will go through the descendant of the current child with the level +1. And we say if there is a child returned from this function, which will be the deepest one. Not necessarily though, no, because it might just block here. Now the first child of the current child might just have no child, but the second one might have one. So can't really do this, can't we? No. Yes. Yeah, we just say move through all of them. If there's nothing, just don't do anything, but if there's something, then we'll compare it to the deepest level. This is the wrong thing to do. So, because the deepest level will always be 0 in every loop, in every recursion. Might have to do something else. This level side. Nah, not really. No. No. Actually, you don't need this. Just say that if there's a descendant of that one, it's the deepest. Okay. Now this is confusing. So if you got the so if the function call on root first, check for the child, and let's say it's have this one, this is the deepest, and it has no child. Then it will be returned. But then, yeah, what if that happened? Like, what if that happened? So let's go. So the first one is go through the roots. Say, is the current child the deepest one? No. If it's not, let's go through the children of it. Well, if it's yes, then let's return this. It returned itself with the level. But we must not return it here. Let's go through, like, let's do this. So the first iterations in the first mass descendant here should be returning this one. And yeah, and we just take it. And then just go through this one, and this is deeper, we'll take this. Go through this one, this is deeper, take this. Yeah, let's do that. So we need a level, fallbacks, and also a current deepest is equal to a option of the tree nodes t. Is mutable. Say if the level that node is more than the current deepest. If there's no current deepest, for example, then current deepest is equal to the current one. Place with the otherwise if it's there. Don't have the level. What's in this level? There's some notes. Yes. If there is that, and if the level is more than the current deepest level, then current deepest place the current node level, otherwise just skip it. Right. And at the end, just have to return the current deepest. Yeah. So let's current deepest map the child. No, you don't have to. You just need to do this, I think. If it's none, then replace it. Continue. Okay, so call on root. Root first call match descendant. This one. Okay, that's the major flaw there. Okay, so we call on root. And we have to check first the current one. If nodes has no child, if nodes had no child, if the callbacks match the current nodes. Otherwise we turn, yeah, so we call on root and say that, okay, is the root had any child? Say yeah, it does. Then we'll skip over this one. Say for its child, or match descendant again. So let's say it's called match descendant on this one. And let's say, does it have child? No, it doesn't have any child. Does it match the callback? Yes, it does. Return it. Otherwise return none. So let's say that it does match the callback and is return something. Then we'll enter here. Say, what is the current deepest? Well, we don't really have a current deepest at the moment because we had root. So just say, can just say that no, there's none, and it will replace the current deepest, this one, and the level here. Then just continue to the next one, and just say it's called match descendant on this one again. Say, does it have child? Yes, it does. Call match descendant on this one. Does it have child? No, it doesn't. Turn something. Say, is the current deepest there? And say yeah. And then, is the current deepest level more than this one? This current level? Or is this current level more than the current deepest? Yes, it does. Then replace it, the current one, and then just go through the next one, next child. Then say, does it have a child? Yeah, it does. Let's go through here, and then just say, does it has a child? No, it doesn't. Place back, and yeah, it sounds about right. And then at the end of it, we just say, oh, what is the current deepest? Let's return it. Okay, that sounds reasonable. Right. Can do and return if let's some child. Don't really care about the level anymore. It's descendant, or well, it's returning, so perhaps descendant. Do we have note? Self. So clone maybe. I mean, should we clone it? Not. Let's pass this in. Yes. And can we? Some child. What do we have here? Expected reference found struck. Yeah. Self level is 0. Current callbacks is callback. Deepest is 0. There's nothing there. Mutable. There's current deepest. None. Get mutable. And okay, callback is a reference. Say current deepest dot app. Notes. Just need note. We don't need the level. That sounds about right. Yeah. Okay. Let's write some tests for it. Get first test get first deepest descendant yeah, then we'll say do we have tests beforehand? Does that? Nope, no, probably not. Let's copy this one. Okay, so the structure we want to have is we have a div. Inside that we have another div. If the div and go back here, so one. And div. So it should take the last one here. Okay, so parent, got parent. It's test node. Oh, test node is just an empty node. Parent is node. Level 1. Be the same as well. One node 2. Then this is node 3. Okay. Then level 2, 1. Two, then level 3, 1. Okay, do that. So parent, let's do parent, level 1, level 2, node 2, append child, level 3, node 1. Yeah. Level 2. Level 1, 3, pen level 2, 2, then we'll level 3, level 2, level 1, 2, and level 2, not 1. And then we'll append the rest. Parent and 1, 1. Two and 3 as well. Good. Right. So we have that tree structure. So what we want is parent. That's deepest. Nodes parent dot get dot find first deepest descendant just return true for now. We just want to find the first deepest one. Don't really care about whatever the condition is. Just want to find the first one. Wanna set that deepest node is something. Compare it. Assert node equal. Okay. Thank you, past me, for writing that function. Now I don't have to rewrite it. Deepest node that we found to be test node. Yeah, we want the deepest node that we found to be equal to the, what is it, level 3 node? Yeah, 3 node 1. Apparently we need to clone here, move it away. Yeah, looks about right. Okay. Now the difficult part is how do we run the tests in Vim? Because usually I use VS Code, but I guess we can use Rust run. We're adding a main function. I don't need that main function. Great document template. Rust runnable. Full. Descendant is 9. Let's hope that that's run. Oh, okay, that's worked. Huh, works at the first try as well. Okay, let's see if we can do the same thing but with some special data. But condition. So let's say in this case we don't want this one. We want this one because it's condition. What is that? Level 2, 2 node 1. Okay. Test node. By test node. Oh, actually not buying, but introducing a new node. Data. Data. Could be a string. Could be a number. Could be number. Number would be better. It's easier. Say U8. Yep. Test node with data. Test node with data. Data. Okay, so this one we need 0, 2, 2, for example. Data 3. Node level 2. Well, we want level 2 node to be something that is 2. Yeah. Let's say there's a lot of 2 in there. And 3 is 3. So that doesn't match. Okay. On deepest node. We'll find with a condition here that node.data equal to 2. Cannot buy. What? Data. Oh, data again. Okay. Okay, so the deepest node must be 2. No. Oh, okay. T. Debug. Get generic there so that we can reuse the same thing again. Cool. Okay. Let's see if that works. It's runnable. Send in condition is 10. Works. Nice. Okay. Oh, we changed that to 3. Fail? Yes. Okay. But if it's because if it's 3, then it should be taking the level 3 node. Yeah, that works flawlessly. Nice. Okay. So let's commit that. Edit, find first deepest descendant for node. Yep. And so we can come back to frame and we can say the deepest scrollable container is the first deepest descendant that that is scrollable. We need to cast it into the layout box first. Doesn't that expected token? Scrollable. Yeah. It's the deepest one is scrollable, then we call scroll container, we call scroll. Alright. If some no. How about now? Yeah. Okay, that works. This looks about right. Let's check to make sure scrollable is... Yeah, not yet. This is just detecting if the box is scrollable, but the overflow property of it could be set to you know, hidden, which will make the box not scrollable. Oh, we'll take care of that later. For now, let's just run it. See if that works. Just make sure that it doesn't break the current behavior. Okay, this breaks the current behavior. It does render a scroll bar, but it doesn't scroll page. So right. Nice. Else, if there is no scrollable container, this might be, and the root node might be scrollable. So case we just need to call the scroll. Yeah. Yeah. Okay, that works. Flow. Nope, that's not working. So yeah, this is the case that I want it to work, because this box is overflow, so it should be working, but it's not. Right. Deepest descendant. that is scrollable. Right, so probably this is the reason why. Okay. This condition is not strict enough. So we want to say some check on this one, see which one you okay. So for now, just add the extra test to make sure that if the element is scrollable. So we're gonna return the content overflow is overflow scrollable. If currently do not have if let's some nodes self.node, because the current box could be anonymous box. Say nodes.get the style or property overflow y equal. What does that return? Return a value. Return a value overflow scroll. It could be scrolls, could be auto, or is auto overflow auto is equal to, well, just get the value out first. So value so we return the overflow value is auto, or the overflow value equal to value overflow scroll. Yeah, so it's either auto or scroll, then that's scrollable. Well, say that we map it here instead of if, and we have then say unwrap or false. Yeah, so if the content is overflow and the content is and the overflow is scrollable, then the thing is scrollable. Yeah, yeah, reasonable. Try it. text. Uh-oh. Okay, it's not even rendering a scroll bar. It's probably because it's the initial box itself is not... Okay. Okay, so we need to handle the initial containing box as well. So... if... is initial containing block self dot parent done. So either must be a low scrollable, or you are containing initial containing block. Say is or else, I guess, or else, yeah, else parent is none. Take one argument. Does that mean closure is expected to take 0? Self parent? Yeah, okay, good. Perhaps that will work. Never know. Yep, that works. Okay. Hopefully that will work with the other case as well. Okay, it's not even showing the scroll bar. Okay. Ah, because it's not scrollable, perhaps? Hang on. Hang on, I'm gonna have to stop the stream for a bit. Okay, we're back. Sorry about that, guys. Okay, we have to wrap this up because I have something to do that I completely forgot. Yeah, so what we have before was in fixture. Overflow. Oh yeah, overflow Y hidden, that's why. So that's why it's not scrollable. So we do it scroll, and we run it again. Then technically It should not break here, and should not break here. Oh, damn it, it's break. It's showing the scroll bar, but it's not scrolling. Why? Isn't the frame? Scrollable. Let's debug it. Scrolling descendant, and this one is scrolling root. Let's see which one will be scroll. Okay, that's scrolling root. Flow. That is still scrolling root. Why? Because there's nothing there. Notes, find first deepest descendant. It should be there. Why is it not? Let's just get the deepest one. Now, see, what does it return? Flow. Okay, that works. But that means for some reason this one doesn't find that one. I wonder why. Deepest node that are scrollable. If it's scrollable, then it show the thing. Let's try patching. Let's try debugging it. Node dot perhaps we can do this. Oops. Nope, that is not cool. Though it did review something cool. Okay, so it does work. It does work. Oh wait, we are finding the first deepest descendant that match. But we actually don't need to be the deepest one. Just need the deepest one that match. Okay. So it could be that this one match while this one doesn't, and we can still take this one. Yeah. Okay. But that should work. The current deepest will still be matching that. Okay, we need to modify this check here. If the callbacks, if the node match the callback, and if the current deepest is none, actually you don't need to return here, just keep going. Yeah, okay, so this, if the current deepest is none, then replace it with the current one. Otherwise, there is a deeper one. If the current one is deepest, then do that. Yeah. Okay. Else. Wait, what? Well, reference. Just need to clone it then. Okay, hopefully that will work. Will flow. Hey, that works. Okay, alright. Okay. So as you can see, we're scrolling the overflowing box. We're not supporting the rendering to clip the content that is half within the box and half without, like half without the box. Yeah. But we're gonna support it soon. But anyway, we got that working. So that's very nice. Love it. Absolutely love it. Yeah. That is what I want. Though we probably have to improve on this one. First, find the first deepest descendant. That is scrollable. Need to improve anything on that check? Just finding the first one that is scrollable. And we should check if it's hovered by the mouse as well, because the node might not. being hover over by the mouse. So yeah, let's do that. Let's notes equal that, and then say notes right, to improve on that one. Let's go there. Yeah, so let's introduce is mouse over. Let's return a boolean. Just return is mouse over. Just a field that we tracked. Take. Let's take. Probably take. We need to borrow it to derep it. Oh, now works. Yeah, cool. So we need the nodes to be is mouse over and is scrollable. Scrollable. Okay, so that if we have two nodes that has the same level that are scrollable, we should only scroll the one that is being, hovered. So got another parents, which it's the same thing. Does the same thing. The bottom, let's say 20 pixel. Run that, and we'll see how that works. This is very exciting. Test overflow. Okay, if I scroll the first one move. Scroll the second one move, but the first one doesn't. Yay! That is awesome. I scroll outside, doesn't work at all. Yeah. Oh, that feels so nice. Oh. Oh. Yep, that works very nice. Okay, let's commit the code. See if we miss anything. Seems to be right. Okay, we'll push the code. Let us make the I want to make a GIF or a GIF, whatever. How do you say it? And then put it in the PR. Mark the progress that we have. Let's see. And we have to wrap this up soon. Hang on. Let's make it smaller. It's easier for coding. All right. What's today? 11 September 2022. Upload it. Which one is that? Is it wrong? To cut it. Paste it back here. See. Ooh, okay, that feels so nice. Yep, I'm happy with that, for sure. Okay, let's wrap this up. Unfortunately I have something to do that I totally forgot, so I have to end the stream here, but we got some decent progress right here. Definitely something to proud of. I'll see you on the next stream then. Thank you for watching my stream. Yeah, bye.